Okie dokie. Let's take a look here in the stomach. So remember, in the stomach we gotta break down food, right? So here's blood. Here's interstitial fluid. Here is the lumen of a gastric gland. Okay, so the lumen, the hollow space inside the gastric gland, remember the gastric pits, the gastric glands, and the stomach. Remember, there are a lot of cells in the gastric glands. One of those cells was a parietal cell. Remember what parietal cells do? Stop the video right now and then come back. Do you remember? HCl and intrinsic factor, okay? So, let's take a look and see our goal, our mission, should we choose to accept it. Our mission, should we choose to accept it, is to make stomach acid to digest our food. Let's see if we can do that. So inside of a cell, of course, cells doing aerobic respiration, making ATP, making the byproducts of ATP, the good ones and the toxic one. And remember, the toxic one is a CO2, all right? Remember what happens when CO2 mixes with water, all right? That's going to form our old friend H2CO3. Carbonic acid. Remember, you don't even have to know chemistry, just count the damn letters. 2 H's, 1 C, 3 O's, all right? Then, like all acids, to varying degrees, depending on they're strong or weak, carbonic acid weak, but it's still going to dissociate. What's it going to do? Well, it's going to come up here and kind of branch in 2 different directions, because as it dissociates, we need to keep track of what's going on. So here, we run into one of our old friends. We have an old friend who moves a couple of things in opposite directions. It's an antiporter. And it sends hydrogen this way at the same time that it is sending potassium this way. It's a hydrogen-potassium pump. So notice we've taken the hydrogen from the dissociation of bicarbonate ion and we've now pumped it into the lumen of the stomach, all right? Then what happens over here, we've got the bicarb ion, HCO3 minus. What we do is we're going to pump that straight over here into the blood, where we're going to have now an HCO3 minus. We're going to come back and talk about him in just a minute. But meanwhile, while we weren't looking, a chloride left the blood, came here, came right through the damn parietal cell like it wasn't even there, and came right here into the lumen of the gastric gland. And what have we done? Oh my God, we have hydrogen and chloride. We made hydrochloric acid. We made it right here. Not even in the basement. We made it right in here, over on the left, right there. That's making it right now. And the bicarb, we're dumping, because we're making tons of hydrochloric acid, we're dumping tons of bicarb into the blood. So remember, the blood leaving the stomach has an unusually high level of bicarb. And what do we call that unusually high level of bicarb? We call it the alkaline tide. The alkaline tide. So blood leaving the stomach is unusually alkaline, unusually basic, all right? Not the Crimson Tide, that's Paul Bear Bryant, last real damn football coach in America. This is also not the all-temperature tide with bleach. Different. This is the alkaline tide. So, there we go. That's how we make hydrochloric acid in the stomach. Is that just amazing or what? Great googly moogly! So, look this over. I would expect you to know how to make hydrochloric acid and why making hydrochloric acid causes the stomach's blood to be unusually alkaline.